Good morning, students. This is Mr. Burke, and we're going to do a review of the Network Fundamentals Part 1 session. Let's go ahead and get started. This presentation is part of Module 2. We'll break Module 2 up into 3 sections. I'll show you the outline of what's covered in each section approximately on the next slide. So let me get the screen share going. And we'll get started. I'll leave the objectives alone for the module. You can read those on your own. This PowerPoint deck is in Blackboard for your review. Here are the 3 parts for the agenda. Today, we'll cover the architecture, network topology, things that are done to secure your network, including segregation, segmentation, isolation. And then we'll cover very briefly some of the security devices and technology in terms of where it's placed in the network for security. Our lens, our perspective is that of security. We could talk about performance, we could talk about reliability, we could talk about function and cost, but our primary focus is to look at everything we cover today from a cybersecurity perspective. In the next class, we'll get into more logical security items, including protocols, internet protocols, addressing, and then in the final section, we'll get into packet delivery, how data is in transit, data moves from one location to another in data packets, and some other topics. Let's keep going. It's important to have context when you look at this presentation. There's so many things in a network, and networks are expanding, growing. The volume of data moving through the networks, the number of devices and the uses, functions, and functionality continue to expand. So I would like to make sure we have context at all times and look at a big picture, and whatever we're talking about, where does it fit in the big picture? So for example, over to the right is a rough example of a campus or university network with wireless connectivity. We may have people in various offices connecting on a local area network. We may have a dormitory, devices connecting in the dormitories or other buildings on local area networks, all on the university network, the internal university network, either hard-coded, hardwire connected, or they're connected via wireless, which is the predominant connection vehicle today. The most important thing to look at is the firewall. That is what controls or defines the internal network and segregates it and isolates it from the rest of the world, from the internet and from other access technologies. Outside the firewall is the internet, all the other domains that users and students may want to get to, other universities, Yahoo, Google, Amazon, and so on. They reside out in the internet. And that's primarily going to be the focus of our security classes. What are the risks that are presented by devices, users, and malicious actors who are coming in through the internet and trying to get to assets in your internal network. Also, sitting off to the right of the internet is a local ISP. ISP is Internet Service Provider. Those are the Comcast, the Xfinities, the Verizons, the Sprints, the T-Mobiles, and AT&Ts that provide connectivity to the internet. I'm going to highlight over to the left, and I'll build this list as we go through the presentation. We have a lot of topics to cover, but I would say stay focused on this list: the protocols, the local and wide area networks, wireless, the various network devices, switches, hubs, bridges, and routers, and how we secure them. Subnets, firewalls, these are different zones that can be installed in a network and how that adds security. Datagrams, that's essentially data. Those are the packets, how we format and structure the data, datagrams, the packets, how they are addressed, how we ensure the data gets to its destination and it's complete. So we'll focus quite a bit on that. There's various addresses that are used. DNS is the domain name server. That's the yahoo.com, google.com, amazon.com. So we have our DNS or domain name service. We have our IP address 9.1.2.3.5, etc. We have a port address, which we'll talk about more later. That is a specific address on the device you're going to. It is a specific address that is reserved for a specific application on that device. For example, there may be a port on a machine for web serving, for the web page. There's maybe a port for file transfers. There's a port for streaming and other services. And then finally, the MAC address. The MAC address is the address that is assigned by the manufacturer when you get your device. So every device that is internet connected has a MAC address. Your phone has one, manufacturer provided address. We'll talk about it later, but your laptop, your phone, anything that is internet provided, connected, network connected, has a machine access control address. We'll talk about the internet, and then the greater concept is defense in depth. What are the layers of defense that we have to put in place to protect our data, protect our assets? And it can start with authentication controls and authorization controls, and physical isolation and separation, and things like firewalls and proxy servers. That's the focus. So let's not get too distracted into features and functions of the network, but rather focus in on the security controls in the network. Okay, quick chart on what a network is. It's two or more devices connecting to share data. An architecture, that's the bigger picture of the network. That is the whole infrastructure, all the layers of technology, and it can include telephone lines and fiber optics and servers and clients and clouds and internet service providers. But it's the big picture of everything that's included in your network. The key with a network architecture is you have to, when designing, you have to balance off functionality, reliability, performance, availability. You have to balance those good things off with cost and security. So your functions have to be balanced against your costs and then against security too. For example, we could have an incredibly secure network, but it doesn't function. Or you can have an incredibly secure network, but it's extremely expensive. Okay. Topology. Now, the topology is within the architecture, is specifically how we arrange or connect some layout pieces of the network, and especially we look at it as users. How do the users connect to the network, and what's the topology? So there, it's really the arrangement of the elements, and more specifically, how are users connecting? Are they coming in wireless? Are they on a local area network? Are they on a ring, a bus? What is the, if you will, arrangement at the user level? Then also here, I want to mention protocols. Protocols, network protocols, those are the standards or the rules that are used for connectivity and transfer of data. And what protocols allow us to do is multiple manufacturers can produce a product, and as long as they adhere to those rules, they can communicate with devices from other manufacturers, other countries. Everybody can communicate together as long as we adhere to the rules of the interface. So that's your protocol. We're going to focus in on the protocols that are wrapped around the internet. That's the primary focus of our class. Okay, architectures. You'll see on this chart a number of examples. We're going to go through a few and highlight which are the predominant, if you will, architectures that are in place. Now, your network architecture could have some of all of these things because it's the bigger picture of everything in your network. All right, some examples of architecture. First, a client server, and simply put, that's over to your right. It's like a hub and spoke or a star, where devices or clients all come into a server at the center of the hub. Um, and the server basically acts as the traffic cop, receives, process data. It might send you on to a client on the other side, but the server, everything comes into the middle, then goes out from the middle. Peer-to-peer is an older technology, but it's essentially where each device, each node can communicate with any other node in the network. So it has multiple connections to your network. This tends to occur in very, very small network environments, maybe in a room that has, or an office that has 4 or 5 employees. Instead of buying a bunch of extra servers to put in the middle, you just have a connection from each workstation to the other workstation. The downfall with peer-to-peer is there are a lot of connections that you have to maintain, and there's no real central management going on. Next, wide area network. That is the bigger picture, which you'll see in the architectural diagram when you have multiple geographic locations, be they buildings on the same campus, or they may be offices in multiple cities, countries, and so on. But in this case, your network spans over the bigger, the internet or other network capabilities to your other geographic locations. And the primary technology used there is routing or routers. Those are those green discs. So you might have an office in Buffalo, an office in New York City, an office in Los Angeles, and you can make it look like one network, but you're spanning, you're connecting by using routers that use the internet to connect to the other segments of their network. Finally, virtual LAN. A LAN is a local area network, and we're going to see some examples of some LANs in a minute. They typically are where people are sitting close together, same geographic location, and they need to work together. They need to share resources. So an old-fashioned LAN is that 3 or 4 people are in an office, they're close by, they have cables that cable all their workstations together. They may also be cabled to a shared printer, a shared fax machine, and other devices. What a virtual LAN is it says you don't need to physically be together. With switches, software, and a network connection, a trunk, we can have people in a LAN connected virtually. So somebody can be in Buffalo and be part of the finance team, New York City, be part of the finance team or LAN, Miami. And what we do is via a network, we connect them together into a logical LAN or a virtual LAN. We'll talk about that a bit more later, but the challenge there is it's good to be on a LAN because we may say the finance team is the only people that should be able to get to their file server or to their printer, and we can connect them regardless of where they sit to their resources. The challenge is that you have extended linkages. The trunk has to be protected and your switches have to be protected from malicious activity. But a LAN or a VLAN is virtually putting together people who work together in a small virtual network, regardless of where they sit. All right, general concerns with the network we talked about earlier. You got to balance all the functionality you want against the cost and the security. So that's a game where you determine what's the risk of having a less secure network if we need more functionality, if we need more or lower costs. And then the other comments you can look at here are basically everything's growing in this space. The number of devices, the amount of data, especially the amount of mobile devices and that is adding complexity. It's putting demand on the network and it's increasing the attack surface. It's increasing the exposures that a network can present. So we have an expanding attack surface. The final comment I'll make is this is the key vector for the bad guys or the attack surface they're coming after, and they'll use automation to probe, scan, your network and looking for open ports, vulnerable devices, and other weaknesses. So automation is actively used to scan and search your network and maybe randomly find a victim because that victim has some vulnerabilities that are exposed to the internet. Okay. We'll talk about how you harden your network in other chapters, chapter 14 specifically. Today, we're going to talk about it at a very high level. Topology. Now, a lot of this is physical setup. I'm not going to focus as much on the physical setup of a local area network. A topology, again, is where the users connect in. We're going to mostly focus in on logical and virtual because that's the future. That's how our networks and especially our local networks are getting set up. We're going to go through the star, the bus, the ring, and maybe a combination of the above. These are the old-fashioned physical setups. First, the star is the hub and spoke. That also looks like client server, but every device comes to the middle, and then from the middle, you are, if you will, dispatched or connected to other resources, or you can send data to other resources, or route your output to your printer, or get your files from your file server, and so on. The challenge here is if that center device goes down, it's your single point of failure. But this is probably the most popular approach for wired connectivity. Next is a bus, also very popular, where every device comes in, and the bus is like a highway, and data is passing to and from, up and down the bus. So there is no single point of failure. The bus may be multiple channels, multiple wires, multiple technologies in place, but there are multiple ways for the devices to get to other devices, be it the printers, the file servers, other user workstations, and so on. The most vulnerable is a ring. This is where we have daisy chained together devices, and the data will flow through each device on its way to the next device, on the way to the next device. And simply put, if a linkage or device on a ring goes down, the whole ring is broken. So you have, again, single points of failure. Okay. Not going to go deep into other topologies, but to highlight a couple of the devices that are either in the layout or right behind the layout. Two we want to point out are routers and firewalls. Routers are the device that will connect one network to another network. In an enterprise, that's where you may have to connect your people in the Miami office with the people in the New York office, which are two different networks. The routers will use that. They'll route through either the internet or other network services to another network, and they're using the IP address to get from one network to another network. Firewall, hopefully that is pretty evident. You can read up on that in the chapter. But that is a device that sits in line in your network, on the network path, that is inspecting and determining what activity or traffic can go through and what activity and traffic needs to be stopped based on security rules. So it is a device, be it hardware or software, that allows you to enforce security. The key concept I want to make here is it's in line. It is sitting in the path. So all data that is flowing goes through the firewall or is inspected by the firewall. Firewalls will have oftentimes signatures. There are very specific things they are looking for to either authorize the data to pass through or to block the data. There are also more advanced and new firewalls that will be looking at anomalies. If they see a tremendous amount of network traffic coming, for example, it may start to shut things down. It may say, hey, I saw a bunch of people try to get to Netflix and try to do log on. It could be looking not only for anomalies, but for unusual patterns or stateful activity where something happened after something else happened that is unusual. So artificial intelligence and machine learning can be applied to firewalls to try to put weird combinations of activities together and try to determine if that activity traffic should be blocked. That's a different chapter. Let's move on. Then there's some other devices in the network. The switches, bridges, and hubs, they're basically the same thing. They're all switches. They're a way to take an input cable or an input signal and either route it to multiple devices or route it to a specific device. A switch is what you have in your home or apartment that allows you to connect your TV and your DVR and your other devices all together. So it's simply like a multiplexer type device that allows inputs in and outputs out. The one thing I will point out, we have a chart on it, is wireless. A wireless access point is a way to get from your wireless device into at least a local network or to a router or modem or something of that sort. A wireless access device is oftentimes called a router because it is connecting your Wi-Fi capability to Xfinity, Verizon, or other internet capabilities. You have a cable coming in your house, you have your Wi-Fi access point or your router there that allows all the devices in the house to connect to the Verizon, Xfinity, Comcast network services. The concern with routers and switches is how do we control and protect them? For example, all of the devices will ship out of the box with default credentials. It is a responsibility of the technicians or the people who set them up to change those default credentials to something more unique, strong passwords, unique user IDs. If not, the default passwords are still in place, and the bad guys know that, and they will probe devices, and they will always try the default passwords first. Routers, since they are connecting networks together, they are susceptible to electronic attacks. Now, I will say the manufacturers that create that have put a tremendous amount of security in, encryption, and other capabilities to protect the routers. But electronic attacks would be the vector, the vehicle for the bad guys to try to come in and hijack the device, masquerade traffic that they'd like to go through the device, or eavesdrop data that is going through the device, see if they can get a copy of the data. A switch, again, is closer to the user. That tends to be more physical. That's wiring and connectivity. A switch also could be used for Wi-Fi access points. We'll see that in just a sec. But again, the key challenge, vulnerability there is that the people who set that up must change the default credentials, the default passwords. And again, they are vulnerable not only to electronic attacks, but they could also be vulnerable to physical attacks. If we're all in the same building, if you're in WOM, if you're in Starbucks and you want to, hijack their router, you might be able to slip in the back room and do something, plug something into their router. Physical attacks tend to be very rare. I think most everything is protected unless you're in somebody's house. But in most enterprises, their technology is behind at least a locked door. Wireless. There's a whole section on the wireless technology, wireless encryption, and other, if you will, functionalities of wireless. Here, we're just looking at how do we set up the access points. And a couple of approaches are one, hub and spoke. That's like a star where every device comes into an access point, and that access point connects to the internet, connects to a modem that's on the internet or a control unit that takes you to the internet, or internet provider. Again, they will connect you to the Verizons and the Xfinities and the whatever service is used to get to the internet. Hub and spoke requires that every access point have a connection back to the internet. Okay, a less expensive way, and it may be a more a comprehensive way to give a lot of access, is a mesh. That's probably what we have in the Howard buildings. There's multiple access points. Maybe there's an access point every 150 feet in the building. So you are always within 150 feet or 200 feet of an access point. You can get a strong signal. But in this case, all the access points are kind of connected together, and only one or two of them are connected to the internet. So you will connect to an access point. It will then pass your signal through other access points to the one that has the gateway connectivity to the internet. The advantage here, again, is strong signals. Also an advantage is cost. You do not have to have 10, 12, 15, 20 internet connections. You can save money on the back end, on the gateway to the internet. Ad hoc is where you have devices that are communicating directly together. You turn your Wi-Fi radio on your device and you can communicate with your coworkers or your peers directly. You do not go through an access point, and that's called ad hoc. Okay, that tends to be rare, but in very small environments might work. The disadvantage to ad hoc is there's no central control. Nothing's monitoring what's going on. It's a free-for-all. All right. So the concerns with wireless, again, we'll have a whole section on here, but let's just focus on the topology. Hub and spoke is you might have single points of failure. Versus the mesh where you have multiple access points, you can just go find another signal. Ad hoc, there's no centralized control or management of what's going on in the ad hoc. Everybody's communicating together. And mesh, although you have very few internet connections, you do have a lot of devices to manage, a lot of access points. So there are many devices and many connections between each of the devices that have to be managed. Here are some exposures you'll see in wireless, some different types of attack. I'm going to just touch them quickly and move on. Again, our focus is on the topology and how you lay out your devices. But if you didn't do things correctly or have the right security, you could have piggybacking. That's where somebody comes in who's not authorized to get on your wireless and connects to your wireless. War driving, that's also like piggybacking, where somebody literally is driving around in their car, going through the neighborhood or walking around the office building looking for an open network. And if they find an open network, they try to attack it or at least use that network. The thing about wireless and access points, there is a limit on your range. You can't be but so far away depending upon the access point. And that may be measured in, hundreds of feet. You can be no further than 300 feet to get a strong signal, or 100 feet to get a really strong signal. So war driving is literally people are physically moving around trying to get close to an open access point so they can attack it. Evil twin is where somebody in your space puts up their own access point, puts up a hotspot. For example, they go into Starbucks and they put up a hotspot and they put a label on it, Starbucks, and people trust that, and people start connecting to their hotspot and they get connected to the internet. They're happy. But unbeknownst to them, you're in the middle and you are eavesdropping, you're copying, potentially stealing their data, but you're not disrupting what they're doing. They have no idea you're doing that. Okay. And then the rest are other vulnerabilities. Sniffing is like eavesdropping. You also could come in and physically steal, get unauthorized access to the computer or device. You could look over somebody's shoulder, and then of course you could steal their device or their mobile device and try to get in that way. Chapter 12 will get into this in more detail. Now, we're going to talk about how we lay equipment out, how we do things to separate, isolate, or segregate, and add security to the network by doing that. The key concept here is physical versus logical. We could always physically separate a network, and there you have to have redundant everything. If you're going to be on a completely separate network from me, I have to have all the switches, routers, cables, and devices I need dedicated to me, and you the same. So it's very expensive to do physical separation, but very secure. Logical is where it appears that you and I are on separate networks, but we're actually sharing parts of the infrastructure, and software and applications are used to separate your network piece from my network piece. And we'll go through a number of examples of that. So again, segregation, the objective is to separate, segregate, isolate one network from another, so one individuals in one can't get to the data in the other. The challenge is when you do separation is you can limit the traffic flow. It may be harder to do your job or takes longer to do your job because we now have separated the paths, the avenues, the access mechanisms. All right, physical and logical, we just talked about. More secure, but more expensive to do physical. Logical is maybe less secure, but it is less expensive. Enclaves, simple term, I'm probably not going to use this a lot, but simply where we put a label on segments of the network, and then we put controls around that segment of the network. And you'll see on the picture on the right, depending upon what segment you're looking at, like the high security data cluster or the management service, we lay firewalls in to manage that, if you will, enclave appropriately. So the firewalls will enforce rules for each of the enclaves. We're going to hit a couple of these things right down the middle. A DMZ, I would like to just touch on that. You're going to see a chart on that in a minute. A DMZ is like, we call it a yellow zone or a demilitarized zone. It is a buffered space where the outside, in this case, the internet traffic can get to those servers in the DMZ, and everybody on the internal network can get to those servers on the DMZ. So it's a buffer zone, a shared space. However, people on the internet can't get beyond the DMZ to the internal network and so on. And people on the inside can't directly get to the internet. They have to go through the DMZ on their way to the internet. And then the DMZ becomes, if you will, the battleground. And if something's bad going to happen, it's going to happen in the buffer. If there's attack, if there's a buffer, I'm sorry, a virus, if there's an outage, if somebody on the outside wants to take all our servers down, they end up attacking the servers in the DMZ, and we can manage and control and limit the damage. And we can also monitor what's happening in the DMZ and quickly respond. Mm-hmm. All right, physical separation, an air gap. Simply put, this is two completely separate networks. You might see this in place in a top secret environment. The government working in the CIA or the NSA, they all have rooms, and the people in those rooms are on completely separate networks. They have their own computer systems and network equipment, everything they need, and they tend not to be connected in any way to the internet. They are totally isolated. It's very hard to break into those environments. It's like on Mission Impossible. You'd have to sneak in over the wall, come down through the roof, find a incredibly unusual way to get in, or you'll have to trick somebody who has authority or access to the room to maybe put a USB device in or something to give you the data. But essentially, from our purposes, air gap is pretty much a fail-safe, cannot be attacked. But at the same time, it's very hard in a air-gapped environment to do your work. You have very limited access and capability, and you definitely can't get out to the internet. All right, logical separation. Again, here's where we want the appearance of separation when in fact we are sharing the resources. A virtual LAN we talked about earlier, that's a way to have, using switches and software, people at different locations appear to be working in the same room and sharing the same resources. So somebody in Buffalo can work with somebody in New York City. They can both use the same printer, the same file server, and only they can get to those resources, even though they're in different physical locations. And they may have a coworker sitting right next to them that's in a different department that cannot see or access the resources that they can get to. Okay, so it's a way to separate people who physically sit together from the data that each of them can see. So a virtual LAN separates the data regardless of where you sit and protects you from people who sit right next to you. Trunking, don't need to know that, but that's the linkage, the network that connects the VLAN elements in one location with VLAN elements or their coworkers in the others. That is the communication line that connects all that together. Other technologies, I'm not going to go heavy into it, but virtualization is another way to do separation. Essentially, we can dedicate virtual machines to a group of workers, a group of users. That is like a server running. So everybody has their own version running, their own, looks like their own server, when in fact it's a virtual environment. That server is running on the same hardware, using the same operating system and the same virtualization software as the other users in their servers. We'll talk about virtualization more in an upcoming chapter, but that is also a way to separate networks and user groups. Zones and conduits, read up on that, but that's mostly seen in manufacturing and process places where you may have a bunch of devices. None of those devices are connected to the network or to the internet, only the conduit. So you might have a manufacturing floor, there are a bunch of robots and computers and sensors in the building, but then they need to get to the network. They all come through a conduit, and that conduit is, if you will, is the gateway to the network, and you need to control and manage the conduit. That is your gateway that has to be managed. Then finally, the concept of zero trust. Regardless of what kind of network layout you have, you can add security by employing zero trust. Users don't like this because essentially what you're doing is continually and constantly asking the user to re-authenticate who they are. If they change and do a different transaction, you ask for user ID and password again. If they shut down and they log on again, you ask them for user ID and password. So as they do things in the application and they do something new or different, re-authenticate, reauthorize. Additional overhead on the user, very good security. Okay, and then a couple of other things, tunneling, encapsulation, VPNs. These are all really examples of taking data and putting it in a protected pipeline. A tunnel is like a protected pipeline. Frequently, it's an encrypted line, so data packets are flowing through a tunnel. The tunnel is protected, so malicious actors, eavesdroppers can't see what's going on. The tunnel then delivers the data, and it is decrypted, decoded on the receiving end. A VPN is a classic example of a tunnel. It is a site-to-site encrypted link. Encapsulation, kind of like tunneling, but it's more on the logical level, is where you have data. I'm going to take your data and I'm going to put it in an envelope. And then I'll just put some addressing and I'll hand it off to the next, party in the communication link. All that party, the next party needs to know is, where am I sending this to? So all they need to see is your address information and maybe some information on the size of the data packets. They then put that in they put the envelope in a box. The box is put in a bigger box, and so on. And anybody who handles each of these packages, if you will, all they need to see is the address until it gets to the endpoint where they start unpacking it. And finally, the end user gets to see the data. So an encapsulation is a way to hide the data from the people that are handling the transfer of the packets, the handling of the packets. Device placement. I'm not going to go through down through all the examples, but what we really need to focus on is when we have a security device, and how and where do we place it? Do we put it in line, which is on the security path, on the network path? So it sees all the data that's coming through, or do we put it out of bound, like the example of the IPS, which is above, which allows it to maybe get a copy of the data and monitor after the fact what's going through. Inline says it can stop activity inline. It can prevent something from happening. Out of bounds is only focused on detecting. So after the fact, somebody may go in and look at logs that have been created or copied, and they will detect something after the fact. So no, inline versus out of bound. Don't need to know all these examples. And so on, inline versus out of bounds. The challenge with inline is it may slow your network down because you're adding some logic and functionality, especially on a robust network channel. That's a lot of data to look through for malicious activity or for anything, any signature in that data that needs to be blocked. All right, security zones. We're going to go through a couple of these. This is also a way to separate, and we put labels on the separation, but this is really how we employ layers of defense. So again, we ultimately want to protect our data, and we do things in the application to protect the data. We do things at the host or the server level to protect the data, and at the network level. For example, at each and every one of these levels, you may need to authenticate who you are, and the application system or the network may also double check your authorizations. When you authenticate, they will look at what are you authorized to do, what are your permissions. The trade-off as you add layers of defense is, again, cost. It costs money. It may affect your performance and functionality. So you're weighing your security against function and costs. Very popular, we talked about it earlier, is a DMZ. Again, that is a set of servers that are placed between an external network like the internet and your internal network. And the outside can get to the DMZ and the inside can get to the DMZ, but neither party can get to the other. The DMZ has limited function. It can be monitored, it can be controlled, and if something bad's going to happen, let it happen in the DMZ where you can respond quickly. You're always watching it, and it has limited impact on the data, the real data that sits in the trusted network, in the internal network. Okay. Frequently deployed firewalls are what are used to build the DMZ. And we'll show you some examples of DMZs here. For example, we know what the internet is. That's the very robust, interconnected world of servers out there that anybody can get to, highly exposed. An intranet is where we have an internal version of the internet, and only internal users can get to it. Outside, external users cannot get to your intranet. So for example, at Howard, there may be what looks like a little internet, and it has information for students and employees and people who are authorized to the Howard internal network only. Much more secure, but again, it does not have all the data that you might find on the internet. And then an extranet is kind of in between the two of those. That's where we allow into what looks like an intranet, but an extranet, we allow trusted partners, maybe our vendors and suppliers and people we work with and trust. They can get to a segment of the network, and that's probably sitting in like a DMZ environment. So external parties can get to part of our network, but they're trusted parties. We know who they are, and typically they're going to come in through some kind of a VPN or secure connection. So we are going to apply security to those external partners. It's not just anybody, and we're probably going to do some level of authentication when they come into the extranet. So you can see the rings here. The most exposed open part is the internet. The extranet, slightly less exposed, but we do have external parties coming in, but we know who they are, and we are applying security to their access. And then the intranet that's our trusted network. That is our employees or users or students. We know who they are and they're all authorized to use our systems, and we are authenticating them as they come in and go out. All right, some additional zones here. Wireless, that's where we put our wireless, maybe certain parts of the building. So you have to be on the first floor, you have to be in the lobby if you want to get to wireless. So it's not all over the place in every place. So you might put it in places where there's also some physical monitoring, maybe some cameras, so we can see if there's malicious activity going on in the space. A guest zone, same thing, is where if you are not authorized to use the wireless and you are a guest, you need to be in a very specific, if you will, part of your building, or you come into very specific access points so we can monitor where the guests come in. HoneyNet, this is an example of putting a copy of your enterprise network out there, but it's a fake copy. It's not the copy that you're using for business, but it's used to attract attackers or to see if anybody's trying to attack your network. And it's a way to observe maybe somebody making malicious attempts to get in your network or to download viruses or to do anything bad. So it's a fake network designed to see if a bad guy is going to come at you. Flat network, and finally, a flat network is a way to create a security zone by taking redundancy out of your network, that everybody in that network comes through a single switch and are connected to a single router on their way to the network, single path. That way we can really closely monitor everything going in and out, compared to a hierarchical network, which is frequently employed, is where you have multiple devices. They're backups to the backups. So for functionality and for availability, there are multiple paths that you can take to get to the internet. A little harder to manage. You may, there are more devices to manage. That's what the security, you're trading off function and availability for the users against security, because there are multiple avenues to get in and out. Excuse me. And folks, this is the end of this section. I put just an information chart up of some of the website portals and some of the commands that can be used in the network space. We'll talk about this more later. But for example, there are websites, if you want to get information on public internet-facing websites, if you just know the domain name, you can find out information about who registered it, when it got registered, what the name servers are, all kinds of information, IP addresses, and so on, by going to some of these websites. WiggleNet has Wi-Fi, public-facing Wi-Fi devices. Data's been captured and put up in WiggleNet, so it's a way to find access points, potentially, that could be tested or attacked. Then finally, we have a list of commands here. These are going to pop up in some of the assignments we're going to do. I think the most popular are ping. Ping is a quick way to check if something is up. You can either give a domain name, yahoo.com, or you can give an IP address, 9.3.4.5, and it'll go send a message and it'll look for an echo back. And you'll see by using ping if something is up or not up, responding or not responding. And then there are variations on the ping command that lets you get a little more information. ifconfig in the Windows world is called ipconfig, but it just shows the configuration on your device. It shows how your network interface is set up. It shows what your IP address is at that moment in time and what other addresses are active in your machine. So ifconfig or ipconfig in Windows are the two quick ways to find out your network credentials. Okay, the rest we'll talk about later, or look them up. The one thing about network tools is if you're interrogating a commercial entity, they may have firewalls and filters up to prevent that or detect that. So we don't do anything where possible against normal commercial entities unless those are the ones that are normally interrogated, like Yahoo and Google. They're used to it. There is also some fake internet sites we'll use. One is called megacorp.1 that we can ping or do a network map against. It is a fake dummy. That is its intent. So we have a couple of sites we can go ping and do other things and not cause any damage. With that, I'm going to pause. Contact me, text me, or email me if you have any questions. And this concludes part 1 of Network Fundamentals. Thank you. See you on the next video. Bye-bye.